All right, welcome back, Fetchers of America. We have cameraman Jordan behind the camera today. Say woo, Jordan. Woo! Yeah, Jordan's on it. Okay, check it out, guys. So we are going to be talking about quadratic equations, and you were supposed to read the packet for preparation today. And I told you in all my emails and communications with you and the announcements that you needed to read that packet for 5.7. Make sure that you've done that, because we're going to go fast through this information. I want you to look up here at the board, okay? In section 2.3, pages 159 to 160, okay? We did problems that look like this, okay? In section 5.7, page 450, we do problems that look like this. I want you to compare and contrast these. Just take a second. Let's look at this. 10 minus 3 times the quantity of 2x minus 1 equals 1. 5 minus 2x equals 3x minus 7x plus 25. 1 half plus 4m equals 3m minus 5 halves, okay? All of these versus these. What's the big difference here, okay? And if you want to look on pages 159 and 160, you can see all the problems share this commonality. Or on page 450, what you're going to be doing it for your homework for section 5.7, they all share this commonality. X squared plus 6x plus 5 equals 0. X squared minus 8x equals 0. X squared equals 16, okay? Jordan, can you see anything that's different about the equations on this side versus this side? I'll tell you guys what, I'm going to help Jordan out because he's wondering a little bit, but check it out, okay? All of these have degree 2, degree 2, degree 2, but every variable over here is degree 1, degree 1. All the variables have a degree of 1, and these are what are called degree 1 equations, okay? And these are what we call degree 2 equations. Alright, now I'm going to take your knowledge a step further today. If you did that reading, I'm going to take you to a higher level of learning, so check it out. Okay, degree 1 equations, alright, all the variables have a maximum degree of 1. And this equals the number of possible solutions. So if we take one of these problems, like 10 minus 3 times 2x minus 1 equals 1, or any one of these, and we do it, so we take the three-step process of solving. Do we have fractions? No. Do we have parentheses? Yes. So we'll distribute the parentheses, which becomes minus 6x plus 3 equals 1, because we're going to take this to here and to here. And then we're going to do the addition principle. Cameraman, can you see all this? We all good?
Yes.
Yeah, okay. And so if we subtract 3, okay, we don't want to do that yet. We actually want to combine like terms. 10 and 3 make 13. Minus 6x equals 1. Subtract 13, subtract 13. That's the addition principle. Negative 6x equals negative 12. Divide by negative 6, divide by negative 6. X equals positive 2. How many solutions do we have? One solution. One solution, okay? So check it out. That is the way all of these problems are. The maximum number of possible solutions, we should write maximum. The maximum, we say max number of possible solutions of a degree 1 equation is the degree. The degree determines the number of possible solutions. So what we have here, three-step process to solving, that's a review. It's written in your packet at the top there. We get rid of fractions, distribute parentheses, combine like terms, right? Apply the addition principle and the multiplication principle. But now these all have equal signs. These all have equal signs. Look at equal sign, equal sign, equal sign. Here, equal sign, equal sign, equal sign. All of our solved problems, they share that in common. But what they don't share in common is the degree. All these are degree 2 equations. Degree 1 equations are also called linear equations. And the reason that they're called linear equations, okay, sorry, I covered into my max there. The reason they're called linear equations is because we have learned that we can graph these, okay? I'm going to erase this. I'm going to try to erase it. It's getting kind of smudgy. Smudgy. That's, oh my God, freeze. That's a fetching mess. Okay, so check it out. If we were to graph these, they become a line, okay? So maybe it's a horizontal line, okay? Maybe it's a slanted line with slope. But these, when you graph these, they all are lines, okay? A degree 2 equation is what we call a quadratic equation. Very interesting. In a quadratic equation, the max number of possible solutions equals 2. Why? Because the degree is 2. So again, if you have a degree 3 equation, you have an equal sign, and something in there has a degree 3, you have maximum 3 possible solutions. Kind of fascinating stuff. You're not going to be tested on this degree 3, degree 2 thing. That's just cool knowledge to know. Okay? But the maximum number of solutions is 2, and we are going to see this. So one of the things that's going to happen here with x squared plus 6x plus 5 equals 0, we're going to learn this. We're going to factor this. That's why we learned how to factor. You know, this goes back to day 1 of class, week 1. Emphasize this over and over again that, you know, we didn't prime factorize for the sake of prime factorizing back on day 1. We prime factorized so that we could find least common multiples. And we don't find least common multiples for kicks and giggles. We find least common multiples so we can add and subtract fractions. Well, people, we don't factor for fun. Factoring is not fun. Okay? We factor because it's a tool that allows us to do greater things. It's a step in a bigger process. So we're going to learn this. I'm going to show you this right now with an example. Then we'll go back to teaching you, well, how do we actually accomplish this? We're going to factor this. Okay, and this is going to be factored with method 3. Why? We'll first check for a common factor. We don't have one. Method 2 would be 4 terms, factor by grouping. We have 3 terms. The 3 terms, x equals 1. So we're going to use method 3 where we say, hey, c equals 5 and b equals 6. And so 5 times 1 makes 5, but 5 plus 1 makes 6. So we put our parentheses, this equals 0. We're going to have x and x, positive 5, positive 1. And then we're going to learn this principle called the principle of zero products, where we say, well, x plus 5 equals 0, and x plus 1 equals 0. And then we're going to go back to our 3-step process to solve it. Now, I don't want to confuse you, but I want you to understand something. Another thing I taught you a long time ago is that the human species is a phenomenal species because we know so little, but what we know, we just blow it up. Okay? Just blow it up, all right? And so here's what's interesting, people. We only know how to solve linear equations. So we use the tools that we have in math and algebra to reconstruct these kinds of equations, like, that's good at grammar there, these kinds, okay? We reconstruct this quadratic equation, degree 2 equation, through the process of factoring and the principle of zero products to create 2 separate equations. Now for you guys right now, if you haven't prepared today, you're like, what all is he doing here? I am going to go back and explain how we came up with all this, but here's the deal. What we did here is we now have 2 linear equations. That's degree 1, that's degree 1, and we can go back to using the 3-step process to solving. Okay, so we have a 5 that's being added, we're going to subtract it from both sides. We get x equals negative 5, and we have 1 and it's being added, so we're going to subtract 1, and we get x equals negative 1. Now here's what's fascinating. How many solutions do we have here? 2. How many did we have here? You know, when we did this problem, which, you know, I can't even remember what we did. I think we got x equal 2 or something like that. I think we did. We got x equal 2 for that. We had 1 solution. Sorry, I erased it. Because a linear equation has a maximum of 1 possible solutions, where a quadratic, because it's degree 2, has 2 possible solutions. Now, I'm going to show you something else really fascinating about this. Okay? We're going to do a little more erasing. Okay? I'm going to erase these. Maybe. We sure are trying to erase. We want to erase. Okay? So here's what's interesting. We have this equation right here. Jordan, there's the eraser man. 10 minus 3 times 2x minus 1 equals 1. And if I tell you x equals 2, because that's our solution, remember we can plug it back in to prove it. So we get 10 minus 3 times 2, which is going to be times 2, minus 1 equals 1. 10 minus 3, 2 times 2 is 4, minus 1 is 3, right, equals 1. 3 times 3 is 9, 10 minus 9 equals 1. 1 equals 1. Check, it's true. So that is a correct answer. Well, here's what's so cool. We can do the exact same thing, okay, with this equation right here. We can take each of these solutions and we can say, all right, where there is an x, we put in a negative 5. So it's going to be negative 5 parentheses squared, because the x is being squared and x equals negative 5, plus 6 times negative 5, plus 5 equals 0. Negative 5 squared is negative 5 times negative 5, which is positive 25. 6 times negative 5 is minus 30, plus 5 equals 0. 25 minus 30 is negative 5. Negative 5 plus 5 equals 0. Indeed, 0 equals 0. Check, that's true. So this is a true solution to this equation. Let's plug negative 1 in. Negative 1. Okay? So, again, what we're going to do, we're going to take this exact same thing. So we know this was a solution. 5 worked, or sorry, negative 5 worked. Okay? And so we're going to take negative 1, put it in parentheses, square it, plus 6 times negative 1, plus 5 equals 0. Negative 1 squared is 1. 6 times negative 1 is minus 6. Plus 5 equals 0. 1 minus 6 is negative 5 plus 5 equals 0. Negative 5 and 5 makes 0 equals 0. And so this is a true answer. Now if we plugged in any other numbers, like let's put 0 in. 0 squared is 0. 6 times 0 is 0, which would make plus 5 equals 0. We'd have 5 equals 0. It's not true. 0 is not a solution to that. We plug any other number besides those two in, it's not going to work. But those two work because those are the two solutions to that polynomial equation. All right. In summary, what I wanted you to gather from all of this is that we are going to be teaching you about quadratic equations. And to make something solvable that's a quadratic equation, we have to use the tool of factoring to break it up into multiple linear equations, going back to our three-step process to solving. Jordan, let's give it a pause, okay? Okay. So one of the things that I wanted to add to that, introduction of the difference between a linear equation and a quadratic equation is, again, an example here would be, 2x, plus, 5 minus 7x equals 12, okay? Everything in there is a degree 1, where here we could have, x squared minus 5x plus 6 equals 0, okay? There we have a degree 2. The linear equation, we said when we graph it, it makes a line. So the name linear equation is really befitting it, right? A line for a linear equation. Why do they call this a quadratic equation? I gotta be honest with you, I don't know. I probably should spend a little more time looking into the origins of this. But I do think it is because it has the potential to hit all 4 quadrants in the graph, okay? I say potential because, we could have a parabola that goes like this or this, but this is not a line. It's called a parabola, okay? And I want to show you something else really fascinating, okay? And we're going to come back to it at the end of the lecture, but I want to ask you guys, how many x-intercepts, okay? How many I can't talk, x-intercepts does this line have? Like, how many times does it cross the x-axis? That's right, 1 time, right there. If you said 2, that's the y-axis. That's the y-intercept. Just crosses the x 1 time. How many times does this parabola here cross the x-axis? Yeah, 2 times. How many solutions does a linear equation have? 1. 1 intercept. How many solutions can a quadratic equation have? 2. Okay? And 2 intercepts, 2 solutions. You'll note that if this is a parallel line, a horizontal line parallel to the x-axis, how many times did it cross the x-axis? None. So we say maximum 1 solution. This is no solutions. Okay? Check this out. Because it never crosses the x-axis. Okay? This one here is not touching this, so it could be no solutions. Or it could, it could go like this, it go whoop, and just go bing, and hit something like right there, and then it goes through 1 time, so it would have 1 solution, but its maximum is 2 solutions. Solutions to equations are their x-intercepts. Kind of crazy. Don't think about it too hard. But we're going to come back to that. Go ahead and pause this again, Jordan. Woo, we're back. Jordan the cameraman, Brother Rich the wild man. Yeah, I'm going cat crap crazy today, okay? Cat crap crazy, you know what I mean? Hey, this is a special announcement for Andrew. Andrew, my man, okay? I told him that I would call him out, all right? Wherever you are, Andrew, out there, enjoy the lecture today. I wish I had some crazy joke for you, but I'd probably get, arrested. So I better not say anything too crazy. Plus Jordan's mother, he'll go tattle on me and I'll be all kinds of trouble. Okay, check it out, everybody. Woo! All right. So there are 4 things that we need to learn. 4 things that we need to learn in section 5.7. The first one, what's a quadratic equation? A quadratic equation, the word equation means it has an equal sign, okay? And the word quadratic indicates we're going to have a degree to. So then you were given in your handout these 4 examples, and these could be slightly different than the examples on the packet, but they're dang close. I think they are correct. Okay, 2x squared equals 0. Is this a quadratic equation? Jordan, does it have an equal sign?
Yes.
Does it have a degree of 2?
Yes.
Yeah, so this is a quadratic equation. 2x squared, does this have an equal sign?
No.
No. Does it have a degree 2?
Yes.
Yeah, but it doesn't matter. It has to have both, and so the answer is no. And so to be a quadratic equation, you must have both of these criteria met, an equal sign and a degree 2. Here we go. X squared minus 6x minus 9 equals 0. Jordan, does this have an equal sign?
Yes.
Does it have a degree 2?
Yes.
Okay, so this is a quadratic equation. Okay, check this out. All right, now we're going to get some clarity here. The maximum degree of 2, okay? So we're adding this to it. We have a degree 2 and we have an equal sign, but the answer here, this is no. This is not a quadratic equation, because the degree of the polynomial is 3. And so ultimately, the maximum degree of the poly, okay, in the equation is 2, okay? All right, guys, let's pause. Okay, so you learned your first principle. What is a quadratic equation? Okay, has an equal sign, has a maximum degree of 2 in the polynomial. Okay, the second item that we need to know is how do we put a quadratic equation in what's called standard form? This is really important. We must know how to put it in what's called standard form. Standard form is this form of ax squared plus bx plus c equals 0, where a, b, and c are the coefficients. We talked about this when we were doing our factoring, okay? So a and b and c are the big numbers, the coefficients, okay? But in essence, what I'm telling you is all the terms have to be on one side of the equal sign. So look at this. Are all the terms on one side of the equal sign? Yes or no?
Yes.
No. No. But good try. Okay? 2 are here, 1 is here. So we're divorced across both sides of the equal sign. So all our terms are not on one side of the equal sign. So we're not in standard form right now. Okay? And then those terms have to be placed in descending order. Do you remember what descending order is? It is by degree of each variable. Okay? And then all those will be set equal to 0. So these are the 3 criteria that permit us to say something, a polynomial equation is in standard form, or a quadratic equation, for that matter, is in standard form. And this is that form, it's in your notes. So if we want to put this in standard form, balance rule, okay, to get this over on this side, because we want all the terms on one side, we're going to add 6. And what we do to one side, we do to the other. We add 6 here, okay, and we get x squared minus 5x plus 6 equals 0, right? Because these cancel each other out and make 0. Now, are these in descending order? Degree 2, degree 1, degree 0 ultimately. Yep, they're in descending order and it's all set equal to 0. So now all my terms are on one side, it is in descending order and is set equal to 0. That is the standard form of a quadratic equation. Let's pause it. Okay, so the third thing that you need to learn in section 5.7 is what we call the principle of zero products. Remember, what is a product? The product is an answer to what? Addition, subtraction, multiplication, or division? It's multiplication, that's right. So the answer to a multiplication problem is called a product. So these 2 things here, if you're looking in your handout, they're being multiplied. Anytime 2 things are next to each other, nothing's written in between, we assume multiplication is taking place. But we don't have to have that written there. We can just have those 2 parentheses, you know, making out, you know, bumping, like, you know, side to side here, okay, you know, okay, I don't know, don't get weird with that, okay, so check it out, a times b equals 0, and what do we know? If a times b equals 0, we know something about a, or we know something about b. One of them has to be 0, that's right, that's why it's called the principle of zero products. So what we see is either a equals 0, or b equals 0, or both equal 0, okay? A equals 0, B equals 0, or both equals 0, okay? I mean, I could literally say to you, Name 2 things when multiplied together equals 0, but one of them can't be 0. And I'll give you $1 million. Yeah, name that movie. Okay? Alright, check it out. For you Austin Powers fans out there. Okay? There are no 2 things. You can't find 2 numbers when multiplied together equals 0 that one of them isn't 0. Some people say, oh, Brother Rich, I got you. 5 times negative 5 will make that. No, 5 plus negative 5 makes 0, but 5 times negative 5 makes negative 25. Okay? Something has to be 0 over here for the product to be 0. That is the principle of 0 products. Hit it, Jordan. All right, Fetchers of America, the 4th and final thing, the culmination of it all. Where we're really going with all this is the purpose of section 5.7 is to learn how to solve a quadratic equation. And the other 3 things that we learn allow us to accomplish that. So up here we have 3 quadratic equations. These are the 3 we listed at the beginning of today's lecture. And we solved this one. We are going to solve all 3 of them. You're going to solve that one again and solve the other 2. But you have these 4 steps. It's written maybe a little differently than it is in your packet, but in essence it's the same. And we can shorthand this. We can learn how to condense this even tighter. We will possibly here in a moment. Check it out. How do we solve a quadratic equation? Okay, the first step is to put the equation in standard form. So I'm going to show you something really interesting here. Okay, I'm going to show you something really interesting here. If this said equals negative 5, is that in standard form? No, it's not. Okay, because all the terms are on one side. If this said, look at this, if this said equals 8x, okay, so like this, x squared equals 8x, is that in standard form? No, it's not. So now none of these are in standard form. So we're going to start them over here. So our first problem right here, okay, x squared minus 6x equals negative 5. Okay, so listen, this is the 4th and final thing you got to learn. How to solve a quadratic equation. For those of you who've taken a future math and you're like, hey, what about the quadratic formula? We don't teach that in beginning algebra. And yes, the quadratic formula does allow you to solve quadratic equations, but that formula is created by doing this to the standard form of a quadratic equation, which that sounds really technical, but ultimately the quadratic formula is derived from doing this to ax squared plus bx plus c equals 0. And we'll talk about that in a future class, not this one. So for now, we're going to learn this process right here. So the first step is we're going to put the equation in standard form. Check it out, folks. That means that I got to get everything on one side in descending order set equal to 0. Okay, so we're going to add 5 and add 5, and we're going to say x squared minus 6x plus 5 equals 0. That's now in standard form. Okay, you're going to understand that the beauty of putting it in standard form, it allows us basically to eventually use the principle of 0 products because we're setting everything equal to 0. So if I factor this, I'm going to create a product of 2 things that multiplied together equals 0. Watch this. Now my next step here is to factor the polynomial completely. And folks, what have we been doing this whole fetching chapter? Factor, 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 factor. Okay? So if you're taking this next test and you're like, what do I do on this problem? Factor. Okay? Because you're factoring everything in this chapter. So we're going to factor this. And we have our 5 methods of factoring. In fact, you know what? I want you to just do this just for kicks and giggles right now. I want you to pause the video, okay? So go ahead and when I tell you, Jordan, we're going to pause it. But I want you guys at home, I want you to write the 5 methods of factoring and the type of polynomial they're possible on. Okay, let's go ahead and pause. Okay, I did it with you. Okay, while we were on pause there, I wrote my 5 methods of factoring and the type of polynomial they're possible on. I keep mumbling my words, blah, 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 blah. Okay, but check it out. I'm going to leave that in the bottom corner here. If you can't see it, you have it in your notes. It's in your visual chart you just made. Okay, so check it out. Method 3 is our possibility. We check for a common factor. We don't have one. And so again, we say, yep, C equals 5, B equals negative 6. Okay, and negative 5 and negative 1, when multiplied together, make positive 5. When added together, make negative 6. And so we're going to have, and this is a little different problem than the actual one we did in the beginning of the lecture. We're going to have x and x here. These are being multiplied, right? Okay, these two. kissing up to each other right there, okay? -5, -1, and yeah, there you go. We drop those two into there. They go here and here. So you have, check this out. Our next step is we factored everything. We need to apply the principle of zero products. This is the beauty here. We put it in standard form so it would be equal to 0. If it's equal to -5, there's no such thing as the principle of -5 products. There's no such thing as the principle of 8x products. But there is a principle of zero products. And the principle of zero products allows us to say, well, hey, I have a binomial times a binomial, and they're being multiplied, and their product is 0. Therefore, the first binomial must equal 0, or the second binomial must equal 0, because a times b equals 0. Well, a is this binomial, b is this binomial. It's not that x equals 0, it's that x minus 5 equals 0, or x minus 1 equals 0. Now we have two linear equations that we can use the three-step process to solve. Because I told you, we don't know how to solve quadratic equations. We only know how to solve linear equations. So we use this process to break these up. We add 5, we add 1, we add 5, we add 1. Okay, over here we get, we get x equals 5, and here we get x equals 1. And there's my two answers. Okay, there's my two answers. X equals 5 and x equals 1. Now, tonight in your homework, I don't know, do they ask you to check your answers? They do say remember to check, okay? And I'm going to tell you that means you're going to plug 5 back in and 1 back in. And if you're taking a test, this is an insurance policy to know if you're doing it right. But if they tell you to remember to check, we're not going to grade you if you wrong or dock you if you don't check your answers. Just get the right answer, okay? If you want to check it, you can. I'm making checking optional, okay? All right, cool. Jordan, write that down somewhere. We're making checking optional. Okay, so we got to tell the graders this so they don't get jacked up. Let's do the next one, okay? I want you to see the beauty of this again, though, okay? This is our process right here of how to solve a quadratic equation. Put it in standard form, factor completely, apply the principle of zero products, and then solve each linear equation. This little equation right here, x squared equals 8x, is it in standard form? No, because all the terms aren't on one side set equal to 0. So we're going to subtract 8x, we're going to subtract 8x, balance rule. We're going to get x squared minus 8x equals 0. Notice how, the problem starts this way, okay? So now, I factor completely. Well, I have a binomial here. It could be a special case, but the first thing I have to do is check for a common factor. I do have a common factor of x. I put this over x, I put this over x, and I get x minus 8 equals 0. We don't factor the 0, we factor the polynomial, right? So notice, the common factor was x. X times x is x squared, x times -8 is -8x. I could check that, make sure I did it right. I did. Look at this. I have one thing being multiplied times another thing. A mono times a bi. Therefore, the mono must equal 0 or the bi must equal 0. The purpose of putting it in standard form was to set it equal to 0 so I could then apply the principle of zero products. So x equals 0 or x minus 8 equals 0. Well, this one's done for us. There's our solution. Yep, x equals 0. Here we're going to add 8 and add 8. Therefore, x equals 8. There's my two solutions. Nice, okay? Last one. X squared equals 16. Can you see it, Jordan? Can you see it in the camera? We all good?
Yeah.
All right. Okay, is this in standard form? It is not in standard form. So we're going to subtract 16, and we're going to subtract 16, and we get x squared minus 16 equals 0. Now it's in standard form, set equal to 0. That prepares us to be able to apply the principle of zero products, but first we got to factor, okay? I'm going to erase my methods of factoring here, but those methods of factoring are kind of nice because it tells us, look for a common factor, look for one, you don't have one. See, we can't group, no trinomial methods, check for a special case. Is x squared a perfect square? It is a perfect square. Is 16 a perfect square? It is a perfect square. And they are the subtraction or difference of squares. So we can take the square root of x squared, we get x, and we can take the square root of 16 and get 4, and then we're going to sing it. Jordan, 1, 2, 3. Put it in a sum, put it in a difference. Okay, so we're going to put this in a sum, and we're going to put those two terms in a difference and set that equal to 0. These two things are being multiplied. Therefore, this is the principle of zero products. So x plus 4 must equal 0, or x minus 4 must equal 0. So we subtract 4, we subtract 4. We get x equals negative 4. Over here, we add 4, we add 4. We get x equals positive 4. Okay, you want to check that out? Negative 4 squared is negative 4 times negative 4 makes 16. 16 equals 16, that's true. 4 squared is 4 times 4 is 16. Both of them are true answers. You can check that one in your head. Okay, let's pause it. Okay, guys, I want you to open up your textbooks for a moment with me. I want you to open up to page 450, and I want you to look at the directions in part A. It says solve using the principle of zero products. Part A says solve using the principle of zero products. Okay, solve using the principle of zero products. Over here on the left side of the board, I have condensed in little small words here how to solve a quadratic equation. There's your 4 steps: standard form, factor, principle of zero products, solve the 2 linear equations. We're going to talk about this in a minute, so just don't even worry about that for right now. What I want you to see here is, notice this part says solve using the principle of zero products. So what they're doing is they're cutting this process in half. They've done this part for you, and they're starting you here on the first, half of the assignment, 1 through, 23 odd. So if you were to do, kind of 1 through 23 here, this is the kind of problems you're going to see. So what I'm saying is they've already factored this puppy for you, and they're saying, hey, this times this equals 0, therefore x plus 6 equals 0, or x minus 8 equals 0. And then you solve each equation. So you do these last 2 steps. They're kind of warming you up. This is what we call progression in sports coaching, where we take a part of the bigger process you're going to do, and we extract it from the game and have you focus on building that skill. And so we're having you focus on these 2 steps before we have you do the whole process. It's kind of weak sauce, to be honest with you, because it's just, you don't need to do this. You're good enough. You don't need to do this. But this is nice for you because it's an easy part of the assignment. So there's your 2 answers right there, and you're good to go. Let's look at this one. This can be kind of helpful. 2x equals 0, or 3x minus 2 equals 0. That's right. This is being multiplied times this, so 2x equals 0, or this binomial 3x minus 2 equals 0. Think about this. Who's sharing sides with x? 2 is, so we divide by 2. Therefore, x equals 0. Okay. Over here, we got to use a couple of steps. So we're going to have to add 2, add 2. And over here, we're just doing 1 step. We'll get 3x equals 2, divide by 3, divide by 3, x equals 2/3. And so, yeah, fractions can be answers to some of these problems. Here we had integers, here we have 0 and 2/3 right there. What if we have 3 things being multiplied together that equal 0? Okay, not a big deal. It's still the principle of zero products. One of them has to be 0, therefore we say x plus 2 equals 0, x minus 1 equals 0, or x minus 57 equals 0. Here we subtract 2, we get x equals negative 2. Here we add 1, we get, x equals 1. Here we add 57, Heinz 57, all right? You don't even know what that is probably. Anyways, x equals 57. Okay, so 1 through 23 odd, that part of the assignment, you're going to fly through that. Let's hit pause. Okay, guys, one of the things that I want you to understand is that we don't want to double up on our lecture for our preparation for the test. So today's lecture about section 5.7, we are covering everything we're going to cover for preparing for the exam as far as solving quadratic equations goes. So we won't review this concept in our review on Monday. Earlier, a few minutes ago, we put a bunch of problems up here with all the steps and we did them. These are all problems from your homework, and we're going to take it a little further for those who are kind of like, whoa, how do we do these? And it's the same process. One of the things I've added up here is that sometimes we have a step 1a called simplify the equation. So if we have fractions, we'll get rid of them. If we have parentheses, we'll distribute them. If we have like terms, we will combine them. Okay? So I do want you to be aware that there's going to be some stuff that requires you to do that. In fact, Jordan, will you come look at number 54 here for me and read 54 to me? Go ahead and read 54 to me.
3x to the second power plus 8x equals 9 plus 2x.
Perfect. Okay, so you have one like that too. We'll do all of these really fast. Okay. So lecture's a little bit longer sometimes because I'm taking a lot of time to do a lot of problems with you. Hopefully that helps you out. Check it out. Okay, 1 plus x squared equals 2x. We know this is a quadratic equation because we have a degree 2. We know it's a solved problem because we have an equal sign. Okay, so the first thing we do is, because that degree 2, we need to rearrange this equation in standard form. So we're going to subtract 2x and subtract 2x from each side. Then we need to put it in descending order. So is 1 going to come first? No. X squared is going to come first. Then minus 2x, then positive 1. So we have an x squared, we have a minus 2x, we have a positive 1, and they equal, these are going to cancel each other out and make 0. So now we have this in standard form. Our polynomial is in descending order, all the terms on one side set equal to 0. Now we got to factor it, okay? We check for a common factor, we don't have one. We don't have 4 terms, we do have 3 terms, a equals 1. So c equals 1, b equals negative 2, and so we know negative 1 times negative 1 makes positive 1, add together make negative 2. Therefore, parentheses, in parentheses we have x and minus 1 and minus 1 equals 0. Okay, and one of the reasons I wanted to do this problem is to show you how to put this in descending order when it's kind of, jumbled up like that, looks a little discombobulated. But the other thing I want you to get here is that we have x minus 1 equals 0, or the exact same equation, x minus 1 equals 0. We add 1, and we get x equals 1. We add 1, we get x equals 1. So what's our solution? Our solution is just x equals 1. There's only one solution here. And I told you that the maximum number of solutions is 2, but I showed you how a graph, it shows that the intercepts, where we intercept something, that is, if we went through this 2 times, we'd have 2 intercepts, but something like this might, the problem might just hit it down here. We go through 1 time, we have 1 solution, okay? Next one. 2y squared plus 12y equals negative 10. Again, it's not all in descending order on one side, set equal to 0. So we're going to add 10. We get 2y squared plus 12y plus 10 equals 0. Okay? Now we need to factor this. We have a common factor. 2 goes into all these. We're going to factor out a 2. Hopefully you saw that. Okay? This is a great section in this chapter. It culminates all your knowledge. You're going to have to use all your factoring skills. Okay? Now we got to factor this trinomial. Okay? C equals 5, B equals 6. Okay? 1 times 5 makes 5. When add together makes 6. And so the 2 comes down. We're going to have parentheses and parentheses. Y, and we're going to have plus 1 and plus 5, and all this equals 0. Now, I want to show you something interesting here. We're going to draw this on this board, and eventually we're going to erase these, okay? We have 1, 2, 3 entities that equal 0. Again, one of the reasons I brought this example up is because, again, I wanted you to have to put it in standard form. 2, I want you to see what happens when you factor out a common factor. But I want to show you something. One of these things has to equal 0. So sometimes students say, well, 2 equals 0, or, y plus 1 equals 0, or y plus 5 equals 0. That's probably, can you see that on the edge of the board, Jordan? Go check that out. Okay?
Yes.
Okay, so thank you. So listen, people, does 2 equal 0? I mean, that's just, I don't know. What does Forrest Gump say? Stupid is as stupid as does, right? This is just stupid. Of course it doesn't equal 0, right? 2 is never equal 0. 2 equals 2. 0 equals 0. So this is not a solution, okay? 2 cannot equal 0, okay? If we factored out a y could equal 0. We had an example like that previously today, but 2 can't equal 0. So then we solve these two, minus 1, minus 1. Therefore, y equals negative 1. Here we're going to subtract 5. Therefore, y will equal negative 5. There's our 2 solutions, okay? All right. I'm going to erase a little bit here because we're running out of space, okay? And so we'll get rid of some of these examples, and we don't want this to be so cumbersome. I want you to notice that part B of your assignment, if you look at the top of the board here, part B of your assignment, part A said solve using the principle of 0 products. Part B says solve by factoring and using the principle of 0 products. And so where before we had this little squiggly line, here in all these problems, the 2 we just did and the rest of these, we are doing the whole process, and this is numbers 25 through 55 in your homework. I want to take this next problem, t times 3t plus 1 equals 2, okay? So check it out. We have t times 3t plus 1 equals 2, and what people do with this is a lot of times they'll get sucked in and say, oh yeah, t equals 0 and 3t plus 1 equals 0. Okay, what's the problem with this? What's the problem with this?
2.
Well, yeah, it equals 2, Jordan says. This isn't the principle of two products, and we can't say t equals 2 and 3t plus 1 equals 2, because there's no such thing as the principle of two products. This doesn't equal 0, so we can't do this yet. So this goes back to this little thing that I wrote over here. Sometimes, before we can put it in standard form, we have to go back and do what we did in linear equations. Simplify the equation. There are not fractions, but there are parentheses, so we distribute them. T times 3t makes 3t squared. T times 1 makes plus t, and then that equals 2. We're going to subtract 2 from each side. Why are we going to do that? Because we want to get it in standard form. Therefore, 3t squared plus t minus 2 will equal 0. And then we check for a common factor. We don't have one. We can't factor by grouping because we don't have 4 terms. We have 3 terms, but we have to use method 4 now. Method 4, that's right. Because a is not equal to 1. So we're going to multiply 3 times negative 2. That's going to make negative 6 because that's our a and our c. B equals 1. And check it out. 3 and negative 2. I told you before, always look at a and c. Okay, it's been a few days since we did our method 4 section in the chapter. But 3 and negative 2 do make negative 6, but when added together make 1. So now we're going to take 3t squared plus t minus 2 equals 0. Break t up into 2 terms based on this. So we'll have 3t squared plus 3t minus 2t minus 2 equals 0. Factor by grouping. Okay, notice what I did here. I'm going to get lazy, put a plus in between. The sign goes with it. My common factor here is 3t. I'll put this over 3t. I'll put this over 3t. And I'll get t plus 1. My common factor here, you could say 2, but you need these parentheses to become the same. So we don't want to just factor out a 2. We want to factor out a negative 2. And so we're going to pull out a negative 2, put this over negative 2, put this over negative 2, and we get t plus 1. And this all equals 0. I'm going to bring this up here. So what we end up with is t plus 1, and the leftovers are 3t minus 2, and this is all set equal to 0, okay? And therefore 3t minus 2 must equal 0, or t plus 1 must equal 0, okay? So here we add 2, we add 2, and we get 3t equals 2. We divide by 3, we divide by 3, and we get t equals 2/3. You have this problem in your homework. I'm going to let you find it on your own. I'm not going to tell you what number it is. I want you to do it, though. I want you to try it. See if you can figure it out. T equals negative 1. There's your 2 answers. T equals 2/3. T equals negative 1. Okay? So we're just cranking through tons of problems, trying to help you guys get as much experience as you can. We're going to do these last 2. If you feel like, hey, I got this, this is a point in the lecture where you could fast forward. We're going to talk about one more concept whoops, about erased that one. One more concept in section 5.7, but then you're going to have a separate video for section 5.8, okay? So check it out. 64a squared equals 81. Okay, is it in standard form? No. Okay, why not? Because all the terms are on one side. So we're going to subtract 81 and subtract 81. I love problems like this. These are special cases, and they're kind of cool special cases where you got bigger numbers that are perfect squares. They're just kind of fun because sometimes people are like, ooh, that's not factorable. First thing we do is check for a common factor. That is not an even number. That is an even number. Okay, there's not a common factor, but 64 is a perfect square. 8 times 8. A squared is a perfect square. A times A. Not 8 times 8, but A times A. 81 is a perfect square. 9 times 9. And they're being subtracted. So this is the difference of squares. So we're going to take the square root of 64. That's going to give us 8. The square root of A squared. That's going to hook up with the A. So those two are connected to each other, so they stay together. Okay. And we have the square root of 81, and we get 9. Okay. And we're going to sing it, Jordan. 1, 2, 3. put it in a sum, put it in a difference, okay? And these equal 0 because it's the principle of zero products. Therefore, 8a plus 9 would equal 0, and 8a minus 9 would equal 0. So we'd subtract 9 from each side, and we would get 8a equals negative 9. We would divide by 8 and divide by 8. And indeed, a would equal negative 9/8. Can you see that down at the bottom of the board there? Okay.
Yes.
And here we would do add 9, and we have 8a equals 9, divide by 8, divide by 8. Again, the human race, what a phenomenal species. A equals negative 9/8. A equals, this is not negative, positive 9/8, okay? This is a fraction, not a negative. Okay. Why we are an amazing species is look at what we've done. Again, we put it in standard form so that we could apply the principle of zero products eventually, and that could break up two linear equations that we can then solve, because we don't know how to solve anything but linear equations. So we use factoring and the principle of zero products to achieve that. This last one, 3x squared plus 8x equals 9 plus 2x, the one that Jordan read to me just a few moments ago. Okay, we just did this one, so we're not looking at that anymore. This is not in standard form. We got to get it all on one side. So we're going to subtract 9 and subtract 2x, and we're going to subtract 9 and subtract 2x. Okay. Now we're going to end up with 3x squared, but the 8x and the negative 2x, they're like terms. We're going to combine them. That makes positive 6x, and then minus 9, and that all equals 0. So what we did there is, again, we had to combine like terms as well as get, all of it to one side in descending order set equal to 0. This problem right here, folks, I'm going to go super fast here. There's a common factor of 3. We're going to divide this by 3, divide this by 3, divide this by 3. We get x squared plus 2x minus 3 equals 0. The 3 is coming along for the ride. We know that c equals negative 3. We know b equals positive 2. Yeah, indeed, check this out. 3 times negative 1 makes negative 3 when add together make 2. Kind of cool. And so we're going to say, yep, x plus 3, x minus 1, this all equals 0. Folks, can 3 equal 0? No. Can x plus 3 equal 0? Yes. So x plus 3 could equal 0, or x minus 1 could equal 0. We solve each of these. We subtract 3. We get x equals negative 3. Over here we add 1. We get x equals 1. Okay, we are done. Let's go ahead, guys. Make sure that you've got all your notes that you need. This little process is pretty important. We're going to pause and teach you one more principle. Let's go. Come on over here, Jordan. Hurry. Give me some high five. Yeah. Okay. So, the last concept in numbers 57 through 63, and you're doing the odds, so you think about it, 57, 59, 61, 63, 4 problems. But you have one like this on the test. And the direction says, find the x-intercepts for the graph of the equation. Now I want you to think back to our graphing chapter, chapter 3. When we wanted to find the x-intercept, step number 1, we always set what equal to 0. Do you remember? That's right, we set y equal to 0. And then step 2, we then would solve for x. Well, check it out. If I set y equal to 0, I have 0 equals x squared minus x minus 6. And what do I have? I have a quadratic equation, because it's degree 2, in descending order set equal to 0. So we're like, can we put that on this side of the equal sign? Remember, standard form doesn't say put it on the left side. It says all on one side in descending order set equal to 0. So you could rewrite this, x squared minus x minus 6 equals 0. These two are the same. They're the exact same thing. But we're going to leave it like it is. Okay? I'm going to erase this one right here. Okay? And so now we have a quadratic equation that we can solve. So we've solved for x. Okay, we got to solve this equation, but we have to solve it by using these steps because I have a quadratic equation because of degree 2. So I've got it in standard form. I'm going to factor this bad boy. Bad boy! Okay? Yeah! And we're going to use method 3. There is no common factor. Check it out. You don't have one. And so you say, yep, c equals negative 6, b equals negative 1. We have 3 and 2, so we have negative 3 and positive 2. And when multiplied together, that makes negative 6. When added together, that makes negative 1. So we have, in essence, x and x, because that makes x squared, minus 3, positive 2 equals 0. Or equals 0 this way, right? Because the 0 is on this side of the equation. I'm saying that really isn't a big deal. I want you to think about this. Check it out. Therefore, x minus 3 must equal 0, or x plus 2 must equal 0. Because we're applying the principle of zero products. We have two things being multiplied, right? Nothing's written in between those. Those two parentheses are bumping into each other. And so we have x minus 3 times x plus 2, okay? And we get to apply the principle of zero products because it's set equal to 0. We add 3, we add 3. We get x equals 3. We subtract 2, we subtract 2. We get x equals negative 2. And those are my x-intercepts. Because, as I stated before, folks, intercepts and solutions are the same. You never knew that before. It's kind of cool. But that's not how we write x-intercepts. We actually write them as 3, 0 and negative 2, 0. Those are my intercepts. If you were to graph this, okay, and I think in your homework in the book, they actually draw the graph. If you think about it, if you have 1, 2, 3, 1, 2, 3, you're looking at 3 is your first x-intercept, negative 2 is your other one, okay? And, you know, this is going to go, you know, kind of like woo, woo, and there you go. There's your parabola. We don't know where that goes because we're not going to learn that in this class, but there is something that tells you where that point of, you know, inflection and deflection is, whether you're pointed up or down, when you learn how to graph parabolas in the next math class. I'm not going to do any more. That explains to you how to do this. That's it for section 5.7. Make sure that you also tune in to our next video, section 5.8. Go ahead and hit it, Jordan.